to know who in this room today, so who is still writing code? Oh, good surprise. Okay, so let's start. My name is Shay, Cohen. Used to work with Juan in Barcelona. Today I'm working at TID-x. It's my 7th year, which I think is like the longest period I work in one company. In the last year, I managed to revive my career. I didn't write really code, I think, like at least 15 years, even more. But last year, things changed a little bit, and I want to share with you my journey. So it all started like 10 months ago, more or less. I was doing my regular annual roadmap presentation to my group and my boss. And once I finished, he said, cool, very ambitious, but not enough. And if in 2020, this was the beginning of 24, if in 2025, we're going to continue to develop in the way that we are working in 2024, we are doing something wrong. Dropped the mic, left the room, and then I need to, I was about to understand, okay, what do I do with this new challenge and information? We did a few hackathons internally, and then we managed to come out with some kind of vision. So what you're going to see, at least a few slides, was like a snapshot of what we envisioned almost 1 year ago, and then we'll continue. So, but before we start, I think that if you're in this room and reading this slide, you guys are vintage. Okay, all of us. Okay. At least, okay. I choose a very romantic expression. But seriously, we are working more or less the same way for many years. Okay, this is just like a schematic personas way of working. We have product, we have developers, we have UX, we have QA, tester. I can add more personas here, but we are working more or less the same way. The tools are a little bit different. We are keep rotating with methodologies. Juan is going to speak about pair programming in a couple of hours. I think it's pair programming, and I think it's like more or less 25 years old. So nothing really changing in general. So, and then like 2 years ago, ChatGPT came out to the market, and hopefully most of us start using it, okay, to our own benefit, regardless what was our role, regardless if we are developers, QA, product, analysis, whatever. So each and every one of us, we're using ChatGPT. Today there are much more tools. So, but nothing really changed. So, in the essence, each and every one of us was working with AI, but then we were the owner of our products. Our artifacts were still, we own them, and then we worked with the other people in the organization. So it's the same. Okay. So what? Instead of working like this, we're going to flip it. Let's try to work like this, which means all of us still need to collaborate, okay? But instead that each and every one of us will work with his own AI assistant, bot, agent, whatever you call it, let our virtual agents speak with other agents and let them collaborate together while we are working with them. Slightly different than the way that we are working. So it's going to be something like this. Okay, the pictures are real person from our teams. So we have everything starts with a product. Okay, so it can be flows, requirements, wireframes, whatever. So we are starting to speak with with a, here it's again, it's in all the slide with a product GPT. In parallel, we have the UX designer that produce Figma, screenshots, whatever that she speaks with a UX agent. This agent maybe can communicate between them. In parallel, the artifacts of these two agents can be acceptance tests, right? From product specs or user stories, we can create acceptance tests. We can have screenshots so we can know what to test. Okay, we can pass this to an agent that's supposed to represent a tester or QA. And obviously, we need also an agent. We need somebody to do the actual work. We can pass him the screens, the requirement, the test, okay? And everybody can speak with each other, very happy family, okay? Hopefully, all of this can produce some code that is integrated, in this case, to GitHub. But the entire point that it's not a one-way flow, okay? It's a system that keeps feeding itself, because even if we have a steady state, let's say that we do manage to get to a working product, it never ends, right? We have bugs, we have additional features, we have changing requirements. So this system keeps, it's a living organism, if you would like. So this was the vision. So it's something like this. We have agents. The human, we understood that in some parts we can remove them. Doesn't sound good, I know, after I'm saying it doesn't sound good, okay? No, but it's still like at least one person. By the way,
why do you need that?
we need somebody to ask for a task. Where is from? We need a CEO, no? And by the way, feel free of interrupting, asking questions. My KPI, the more interaction or interference, for me it's a better talk. So again, so this was the feature, and this was the vision. And today we're already seeing, at least in some areas, something that looks similar to this, not with all the agents, but in terms of a black box system. So who is familiar with Lovable? Okay, Base 44, an Israeli guy, one-man show, amazing. But again, there are Replit. There are a lot of products that you can enter. Say, okay, this is what I want. Build me this. It's building a very nice demo. Okay, a very nice. So it looks like it's possible. Okay, let's slow down. Let's speak a little bit about agents, and then we'll continue. So we have what we call like a zero-shot agent or bots. This is what all of us are using, hopefully. Okay, so we have some kind of agent. We're asking something in text. We're getting a response in text. Okay, on the right you can see a template. We have a persona. We have the task. We can specify the audience. How do we want the response format? All of this is optional, but in theory, very simple. Again, if you're using ChatGPT or Claude or Gemini, you're doing this. So what is agentic? So I asked this morning Claude. Okay, so agentic is coming from the word of agency, which came from Latin, and which means the one who can act. Okay, and if you're taking this into agentic, okay, this means you have agency, so you have the ownership, the autonomy, okay, to take action, to take decision and actions. Okay, and if you're taking this into AI, okay, and this is a script from, you have to believe me, 7:30, just before Juan was calling me to come early. So in the aspect of AI, agentic means an agent that can plan, okay, create subtasks, and then execute, and if he needs, adjust the plan and act according to the reality. Okay, sounds very bombarding. Okay, what does it really mean? So it's something like this. So it's a very similar agent, but the main difference is it keeps feeding itself. Okay, it keeps feeding itself from the previous results. Okay, the previous results, this means we have additional context. So again, those of you who are still writing code in the old way, but with AI, or writing some code, you have some kind of output or error, you're doing copy paste, ChatGPT, you're getting a response, going back to your IDE, and this endless loop of copy paste. Okay, many people are doing this. In the last half year, there are Cursor, Windsurf. Who uses? Only 2, 3. Okay. And now I just read in the break that Microsoft Copilot. So Microsoft Copilot they released last month also an agentic IDE, and just today they mentioned that they also released MCP. MCP is a protocol, and we're going to discuss this in 2 minutes. It's a protocol of extending agents with tools. Okay, it's, MCP stands for Model Context Protocol. It's like a standard protocol that was created by Anthropic, the company behind Claude. And just last week or 2 weeks ago, OpenAI also adopted that protocol, which means it's going to become like the, I told Juan in the break, it's like it's going to become like the Bluetooth of AI. Okay, this means you can connect other components, either standards or something you built your own, because it takes no more than a few hours to build this kind of extension, to extend this feedback loop, because this feedback loop, somewhere here there is an LLM, a large language model, but it doesn't have anything else other than that. And this is where it comes to agentic AI plus tools. Again, so agents, we are text in, text out, okay? But when we are introducing tools, it's the capability of the agent to go beyond the language model and to act upon it. So it can be calling an API, making a local change on your files, doing some kind of search. This is like connecting the agent to the real world in order for us to stop doing the copy paste from ChatGPT to our IDE or whatever tools that we are using. So how does it look like? This is a very simplified way of working on an agentic system. So everything starts with the user. Yes, Gustavo, we still need a user. Is asking an agent to do something. So this agent is consulting with the model. Okay, what do I need to do about this? It breaks the task into subtasks, plans. Each and every agent is doing it slightly different. And then you have a few options. You can either delegate or communicate with another agent, usually in a different role, or you can just use a tool. So these tools have outputs. The outputs are going back to the agent, which give it back to the LLM, and then the cycles continue. So it's like a huge recursion, okay, that of agent calling tools. Hopefully, eventually, everything is being concluded into the task that you wanted to achieve. It could be paying a trip to Madrid. So let's say I have like an orchestration agent. Okay, that can ask the user a few questions. Okay, when are you going? What is your preferred way of commuting? Okay, and then delegate it to a research agent that will do some searches. Maybe he will open a browser. Maybe he will scrap some sites. And then once it will conclude, you can use an email tool to send the plan back to the user, assuming that this is what the user asked for. Or in a similar way, we can have we can ask an agent to write a chess game. Who here asked Claude to build an HTML simple game? Okay. If you don't, try it. It's fucking amazing. Okay, you have it. it renders the HTML. If it's basic React, it also renders it within the client. It takes like 10 seconds. It's a kind of magic. But in theory, we could build a system, again, to do some research. What is this game all about? What are the features? Assuming that the model doesn't know, you can ask the user, okay, what kind of features you want in your game? And then delegate it to a coding agent that will write files, run some shell scripts, even do some Git or GitHub actions, and then delegate the results to a testing agent that will do his part. If our agent is doing TDD, then we're going to start with the testing agent and then moving to the code agent. But then it all depends on the way that we are guiding our agents or our system how to work. So this is something, nobody here will probably know what is just forward to Shraga. So it's a phrase from Israeli sitcom that we had in I think it was like 10 years ago. To make it very short, I will not show you the movie because you will not understand. But in very short, so there is a Israeli sitcom. In one of the episodes, there is a guy which is a kind of a pothead. Somehow he managed to get into high tech in a position, and somebody's coming to him. The SQL server is down. Okay, it's your responsibility to take care of it, and obviously he doesn't know what to do. He's asking somebody, is in office, okay, I don't know what to do, the SQL server is down. And so you tell him, okay, so what's the problem? It's heavy. But so you tell him, okay, did you send an email to Shraga? Shraga, it's an Israeli male name, a very old name. He said, no, he told him, okay, just forward to Shraga and he will take care of it. So the entire episode, he keeps forwarding emails with tasks to Shraga, and automatically these tasks are being fulfilled. Nobody sees Shraga, nobody knows who is Shraga. At the end of the episode, Shraga has been relocated to the States, and this guy is forced to leave the company because he actually doesn't know how to do anything. So this was the inspiration. I want to forward task to somebody that I don't care who it is. It is just there, and I can just forward any task to him, and he will do it. So I call the tool Shraga. Okay, so in a very high level, by the way, this slide was prepared by Shraga, not with this style because it doesn't. His slides look more or less like mine. But so Shraga is an agentic AI agent that knows to get a task, to break it, and then to follow according to his plan. If the plan changes, he will adapt. You have like a sample output of Shraga in Slack. So again, so the reason I'm showing Shraga just to, it was a kind of a rolling prototype to see what we can do with AI and to inspire different activities within the company which are related to AI. So as I said, Shraga is taking one task, he's breaking it to subtasks. Okay, you have different agents. The general agent is the main agent, like the most obvious one, and then we have different other agents. You can also create on-the-go new agents, but it doesn't really matter. We have a lot of tools. So the tools can be file operations, so you can read and write files. You can search for files in the local directory. You can execute code, which means we can ask the LLM, okay, create a code to do X, Y, Z, and then we execute it. So it's like the most powerful tool because it can create its own tools by that. You can execute a shell script. If you have a knowledge about the API, regardless where he's familiar with that API, from search, from the guide that we gave him, from the actual model, unless he's missing some kind of a token or authorization, we can give him the authorization, he will just call the API. A question tool is just a way to interact with the user. We have image analysis, we can scrape sites, download files, web search, and I would say all these these are tools most of them are very easy to implement. When I spoke just before about MCP, so this is a pre-MCP. So it's not formalized as an MCP, but it's a matter of hours to convert them into MCPs. We can automate actions if it's running on a Mac. With mobile automation, web automation, Selenium, Puppeteer, Playwright, a lot of Google Suite APIs. Again, if you think of it, these tools are just a proxy to a public API. This is why for the LLM, it's very easy to learn how to use them. We don't need to train it too much because most of these things here are public knowledge, and a lot of internal tools that are related for mostly for enterprise software companies. So we have a connection to GitHub, Git, Jira, Monday, Slack, and email. Email was like the inspiration just to send him an email, and eventually he will come back. And Sentry for collecting error from production and acting upon them. Okay, just before the demo, questions? As I see it, we have a new software paradigm. So up until lately, most of our software was orchestrated, the code and the workflow was literally hard-coded within our software. So we might have configuration, right? But the algorithm was still in the code. And then 1 year ago, many of us started using LLMs and empowered our software with API calls to large language models. So it looks something like this. Okay, so we have like a plugins, so we enriched our software with the power of LLM, but still it was this. It's still the same software. Okay, you have some. Okay, here we can generate tests. Here we can generate images. We can do some planning. We have much powerful more software, but at the end of the day, the logic is within the code. And now we are starting to shift to a new paradigm. It's still doing his baby steps, but this new paradigm means that the LLM decide what is the software going to do, not us. And the legacy, the old way of working, the actual code will be triggered by the LLM. So like the equation is like reversed. Okay, it's a little bit slower this way because we need to go every hop we need to go to the LLM. It can take between 2 seconds to 1 minute. It's slow, but some people is calling this like the death of SaaS. Okay, because assuming that we have API or access to our databases, we can perform anything, any logic just triggered by the prompt. And we don't need to write all this sophisticated logic. It's still time will tell, but this is the direction. Again, not every software, but it's a new way of writing software. Okay, let's see a demo. So as I said, in case of Shraga, we have email. It has a connection to, in our case, Twix to Slack, so every employee can use it. But it also have a command line. I will use the command line. Okay, big enough? Okay, so let's start with the most popular task. 1 + 1, what will be the result? 2. Okay, it's a little bit slow. So how come again, I'm delegating this request to the LLM. By the way, I'm using Sonnet. Let's hope that everything will work. So how does the model know that it's going to be 2?
Because it knows or because it uses a function?
No, in general, if I will go in now into...
Because it knows.
What does it mean it knows?
That's in the memory. 1, 2, 3. The most probable output.
Yes, statistically, it knows that 1 + 1 = 2. Okay, so in the past, usually my next, when I'm saying past, it was just like 2-3 months ago, I would do 2 power 3, and then statistically, it didn't know the answer, but somehow the models are becoming very, very powerful. So let's do this, power 10, okay? Wait, and just add here a debug so we can have a glimpse of, look, what is happening in the background. So statistically, the model shouldn't know this, okay? So as I said, if you remember the diagram before, if you are getting a task, okay, and we cannot perform it, we can either delegate to an agent or a tool. What tool do you think you will choose? Calculate. Code. Okay. So no. He didn't choose a tool. He decided to do it by himself. Let's complicate it. Let's do something else. You know what? Find the largest prime number below. Okay. So again, so the model shouldn't know the answer for this kind of question. Okay. So what I'm expecting him to do, like I was expecting before, and this is the beauty. It's very dynamic. He has his own free will and depends on the model. So he should decide. Okay. Okay. So let's see what happens. So this is the plan. Implement primary test function, create function to find the largest prime, execute calculation, and verify result. It didn't finish yet, but in any case, so it chose a tool which is called the code execution. Okay, this is the inputs that he chose. Oops. Where is it? Here. Okay. I'm giving a 3 option. You can do Python, TypeScript, or shell script. It chose Python. Okay, you can see here the code. The code is printing the result. Okay, this is the output. Okay, this is the output of the tool. So the LLM send back, run this tool. Okay, this is the input and output of the tool. The agent return back the response to the LLM. The LLM decided that he had enough information to conclude the tool, and this is the very nice output of the LLM. Very basic tool usage by an agent, which was like, actually there are 3 because there is additional validation step that I'm doing just to make sure that he actually did what he said he did. Questions? Okay, let's use something else. Okay, let's see if it's going to work properly. Okay, what is the weather today in Tel Aviv? Sorry, Madrid. It's a habit thing. So the model doesn't know where I am. Usually it thinks we are somewhere in the early 24. So he decided to choose, okay, a Google search. Why? Because you have a Google search tool. Okay? So he's doing a search, and in this case, it's going to be, so you see, you understand the date of today. It was relatively short. Sometimes it's things are getting complicated. He's opening browsers. It's not always working as expected. This is the caveat of this kind of system. Okay, so
How do you find the date of today? Do you have a tool for that? Or
no, actually, I embedded in the prompt today timestamp because if you're asking, okay, find me something for the last week, then it was again somewhere in the early of 2024. But sometimes the validation tool doesn't like it because you say, okay, you said that today is 2025. I don't see any evidence of that calculation. Let's add to this prompt, create an amazing HTML page for it. Okay. Actually, I'm hoping you're not going to choose a coding agent, because if he's choosing a coding agent, things are becoming a bit more slow, and I don't know how much time we have. Let's be patient. So he's supposed to do more or less the same. You know, find, okay, what is the weather today in Tel Aviv, in Madrid, and okay. Now he decided to do something else. So he decided to use the web automation to open a browser, headless true, which means we don't really see the browser. We can ask him to do headless false, and then we will actually see him opening the browser. I'm not sure if it's this, he went to the same place, but while he's writing, let's open this folder, and we'll see that we have the weather. It's still, oh, he didn't finish yet. Oh, wait, he didn't finish yet. Where is it? He still didn't finish. So we created a file before he finished the operation. Okay, let's use this as an example of what's happening with the web automation. So obviously he doesn't know where is the site. He doesn't know that site. He doesn't know it. Okay. So actually, what happens? But he has a plan. He wants to extract the weather from weather.com. So he's using the tools that I gave him. So one of the tools can be extracting different selectors or extracting the text out of the site. He's like trying to guess, because again, he doesn't know that website. So he can look at the DOM, do some selection. There are some limitations because the page sometimes can be long, but eventually, okay, he didn't manage to do it. Okay, and this is the beauty. When he doesn't manage to do it, so again, for him, an error is just an output. Okay, I didn't manage to succeed in my action. I will, it's like Waze, I will recalculate my path. Okay, in this case, he decided to go back to Google search. I'm not sure if he's finished. Yeah, he finished. And this is the beauty, because we know that LLM are sometimes, I would say 80–90% of the times they're right. The other times they are wrong. Okay, or they have a missing information. And if you have a multiple iteration action, eventually we are getting something broken. Okay, but if we have a feedback loop that we can just notify him that something is not working as expected, in most cases he will figure it out and come up with the right answer or the right solution. Okay, I'm not sure if it's gonna. Okay, it's been updated. For some reason we are in Fahrenheit. Never mind. How much time do I have, Juan? Okay, so let's do something slightly different. We were talking about okay, let's do a very simple. I'm just moving to a new tab to have a cleaner context, and I'm going to ask him to create a very simple TypeScript loan return function. Okay, let's bring it to the product. Let's go back. Okay, it was a very nice demo to understand the way that the LLM or the agent works. I'm going to ask him to write a very simple TypeScript function, but I'm also asking it to write tests. Okay, because we know that in the real world, without tests, we are doomed. And test is part of having this feedback loop to know whether what we are doing is working or not. Okay, so let's see what happens. So we started with writing files. Let's see the files. Right. Okay. So we have the loan TS and the loan test. Okay, so we created these files, and then is running npm test for them. Usually they fail the first round. This is the output. Okay. So this output is fed back to the LLM. Okay. And now he understands that you have no, I know, okay, package JSON. We started from scratch. There was nothing there. Okay, obviously we could warm up the system. We could start with a template, okay, which would speed up everything and will avoid a lot of pitfall that we have usually when you're creating a new application or a new project. But for the sake of the demo, it's nice because you see that every failure, if we, okay, we can revive from it. So, okay, so it created a package JSON, right? Here, you can see it, right? Okay, it created a package JSON, and then he installed the missing packages, and install and run in npm test again. Okay, now we can see that, okay, we have 3 out of 5 tests that he wrote are passing. Okay, which is a good start. The fact that he managed to run the test, usually this is like the most trickiest part, just to make the test to run, not pass, just run. Once we're starting with the jest configuration, you need to become a believer. Okay, so again, so this jest failure is fed back to the LLM. It's still failing. Come on, no progress. Up. Now we see we have only one failure, okay? And eventually he will manage to do it. Okay, no, I chose a very simple a task in order for him to succeed. It will be very shameful if he won't succeed. But this is life. By the way, but this is an example. Let's hope he will finish. We are embedding, for example, logs files within our code in order to help him. And again, we have additional feedback loops like we do. Oh, it's finished. Okay, so let's see if it's okay. When it's passing, we don't see the output of jest. So let's do small play. Let's open one of the files. Where is it? Let's break one of the tests. Okay, I'm gonna, let's put here 4. Not sure what's gonna happen. Okay, and let's go back here. Validate the test are passing, fix code or test if needed. Let's debug. Okay, so again, so I don't know, at least we change the test, right? So, okay, 4. So at least one test should fail. Questions while we are waiting? So first of all, I forgot to mention it, but at least this agent is quite stateless. So when I run it again, it doesn't know anything about the previous. The only thing he has is the files. So it starts with reading the files to understand, okay, what are we dealing with? Okay, because he doesn't even know what these files are there for. We need to understand it from the files. Oh, that was fast. Oh, okay, it's 0. So he read them. They are still passing, no?
You should change the value and not the precision in the test. You change the precision.
Oh.
Instead of changing that 4, you can change the previous.
For this, I need a developer. Again, what was it? I never saw this code before.
Change the best argument instead of the same.
Okay, this one. Okay, let's run it again. Lucky we have Gustavo. So we do need a person in the slide. Sorry?
Did you save the file?
Yes. Okay, perfect. Now we have a failed test. So while we're waiting, obviously this is a very, very simplistic, naive example. I'm sure that many of you have done more sophisticated things, but in theory, but not only in theory, in practice, this kind of agents can deal with repos with a lot of code, okay? Yes, it might take a few rounds in order to find the exact file or files that are related to the task. So in this case, the task was very ambiguous. Just find what is broken and fix it. But it can be adding a new feature or creating a new system. I think that we are in the right path here. While let's. Okay, I think it's changed it back, right? Okay, so it will pass. Let's do something slightly different, but again, just in the areas of our world. I'm not going to change more code. Let's do this one. Okay, so if you remember, in the list of the tools, we had the Jira tool. So here I'm instructing him to review. This is like Wix, OneUp Info. These are the names of Jira projects in my groups, and I'm asking him, okay, review the last 3 months. Okay, you see that it's an old prompt. I gave him the date just to make sure he's not looking at the 2024. So actually, what will happen? You can see that again the LLM decides. Okay, is choosing the Jira tool. It decides what params to pass to this tool. In this case, it's a search, and it can do slightly different searches. Okay, it will get the Jira tickets, and then he will perform whatever I ask him. In this case, I ask him something very vague just to summarize it, but I could ask him whatever I want, because once he have it, we have the power of the LLM. The only limitation in this kind of scenario is the size. And the size is derived by the model that we are using. Again, I'm using Sonnet 3.5, it says 200K, but if I'm using Gemini, it's going to be 2 million. So here you can see, it didn't take too long, but I have a summary, okay, of the Jira tickets of my team, and obviously I could do something similar with this in GitHub. I can create a PR, I can create a PR review, I can do a code review. We can do many, many things. If we're looking back at the diagram of all the agents are working independently, we believe it's doable, okay? It's doable for a certain kind of tasks, okay? Not all of them, but we have to start somewhere. I think want to see another demos, or let's leave time for questions. Okay, time for questions. Okay, I think that. Yeah. Oh, okay. Okay, so questions.
Did you do this from scratch, or did you use something?
So in case of Shraga, it's totally from scratch. I started, I think it was July last year. It was some kind of a side job. Today, there is much more standardization. There is a way of instructing the LLM what tools to use or what functions. When I started, there was no such a thing. Same goes for the tools or MCPs. So today it's much more standard. But everything from scratch. So part of it was for me to learn, okay, what are the capabilities, and I wanted to understand what can I do and how to do it. So as I said, it was more like an inspiration. I didn't expect it to become an internal product. And by the way, there is even a team that is developing this for our users. Again, this wasn't the intention, because you can just give them a task. Sometimes it can take minutes. It depends what is the task. I have to admit, most of the cases is getting the job done.
What kind of infrastructure do you need in order to run this design?
So what you've seen, it was running locally, okay? Yeah, it was running locally. The only thing we have some kind of a serverless lambda just to interact with the LLMs. So I cannot keep the API key of the models locally, but in theory I could just call OpenAI or Sonnet APIs directly. So we don't need anything else. So this is a mostly client-based application. So there is a lot of open source that could help you build something like this. Is like connected to your question. I don't know, LangGraph, AutoGPT. Today there's a lot of tools that could bootstrap this kind of system much faster, but still you need to decide the way that this system behaves. So it just gives you the infrastructure, but it can be achievable.
Do you have any guardrails in place, like for example, to prevent it to remove all the Jira tickets from Jira or something like that?
Yes and no. So in some of the APIs, for example, with GitHub, you can open a PR, but you cannot merge. Okay. When we are giving access to files or directories, or we are limiting. So if you could remember, not this one. So I'm passing him a directory. So it's supposed to be limited to that directory. When we are opening a child process, is limited by the OS to using this directory. But for example, if I'm asking him to run a server and the port is occupied, what he will do? He will find the process that occupied the port and he will kill it. Okay. Okay. But again, it depends on what I'm allowing him to do. In my case, I was a believer. On my machine, I'm letting him to do almost anything. So in theory, he can do harmful things, but I haven't seen it yet. But to ask for your question, he can spam Jira or GitHub as much as you want, but we didn't. It depends on the prompt. We used to have a feature of creating tasks, like schedule tasks, but I closed it after 1 week because the developer was like trolling each other, send Gustavo every morning a joke, this kind of things that were like repeated, so we just killed it. But this was, again, it was human intention that was evil, not the model. More questions?
What's your opinion on the frameworks, TID-x or LangGraph, LangChain, or any other?
I think, all of them are great. You need to work with them in order to find, what is suitable for you. For example, if you're using if you prefer to work, so in the case that I presented, there are like there is one general agent which is like the orchestrator, and he can decide whether to delegate or not. So it's a kind of you have like an hierarchy of agents. Some people choose just to work with one. Actually, I'm not even sure which approach is better. One agent that does everything, or different ones. Some people prefer like a crews, like teams. Okay, you have like a team, you're giving one job, and then to another team. Some prefer to give each agent different tools. In my case, I decided I'm giving all the tools to all the agents. There is a cost because the context windows, every time I'm sending in a request, I'm sending all the tools as a menu for the LLM to choose. So it's both pricey and slower. On the other hand, he can decide whatever he wants. So if I have a coding agent and he decides he needs to open a browser, I don't know why, he can. Okay, or if you want to search it in Google, he can. So maybe in the future we will limit or make it more precise, but I think it depends. So this is like a very general purpose agent. In most cases, you will do something much linear, very focused for the job. So if I would need to write just a coder agent, I would do something much more slim, with a very, very specific workflow. In this case, even if I'm instructing him, the flow, there is a 30% chance that he will do something slightly different, which is sometimes it's problematic.
Did you